Hello, and welcome to Enclosure Institute, presented by Marian and Rogers Corporation. I am not Jimmy Budd, and this certainly isn't Phil Taylor, but we are special guests from 3M, here to talk about 3M adhesive technology, bonded to Rogers BISCO, and pour-on products.
I'm Nick Labelle. I'm an application engineer with 3M's Industrial Adhesives and Tapes division, supporting our converter markets area. And specifically, I support our converter network with end-use customers trying to help solve their design challenges.
And my name is Jordan Prins, marketing at 3M's IATD division, specifically aligned to converter markets.
Hey, Jordan, I did the study, but why are you here today?
Well, I know that 3M and Rogers are two main suppliers in the industry and often complementary products, and I'm here to learn more about what you found out doing the study.
Before we get too far ahead of ourselves, let's cover why it's important to select the correct adhesive.
That makes sense. So what are some of the variables customers need to consider when selecting an adhesive?
Well, some of the things that we want to choose is we want to make sure we're getting the right adhesive for the substrates or materials that we're trying to bond together. And part of that is thinking about the compatibility of materials, but also the environment that they're going into, right? We want to make sure that they're compatible with the temperature, the moisture exposure, chemical exposures, and ultimately, can they support the loads that the adhesive will be subjected to in the application?
That makes sense. So for this study, what specific Rogers products did you evaluate?
Yeah, so we looked at several different Rogers formulations, especially the Rogers pour-on materials. So things like the 4701 series, the HT series, AquaPro 4790 through 92, MF1-55, etc. And we also looked at some of the Rogers BISCO silicone materials as well.
And then what were some of the 3M adhesives you tested in the study?
Yeah, so we looked at some of our different adhesives that really are designed to promote different properties in the application. So the key ones that we looked at were 5mm adhesive transfer tape, so pure films of adhesive from our 300 MP Plus family, so 9775 WL Plus, our new 300 LVC family or low VOC family, so that's product 59812 LVC, 300 LSE, and product 9472 LE, and 200 MP. 468 MP, and we also looked at our differential double coated product 9731, which is a silicone acrylic differential product.
Got it. So you got the products, slapped them together, and then what?
Yeah, so we tried to use an ASTM method, or an industry standard test method. So this is ASTM D1876, which is known as T-peel. And essentially we're taking the material and we're putting our adhesive on there. So we're taking a Rogers pour-on foam, we're putting our adhesive on there, and then we're adding an aluminum foil backing to it. And we're pulling it apart at a controlled rate of speed, at basically very slow rate of speed, trying to look at, does the adhesive adhere? And we're going to measure a few different properties out of that.
Yeah, that all makes sense to me. So how do you know which one worked best on the different 3M adhesives versus the Rogers materials?
Sure. Yeah, so we're going to look at a combination of multiple different things. We're going to look at the data, the numbers, right? The resistance to peel force as we're peeling these samples apart. We're also going to combine that with the failure mode. And where that's really important is not all adhesives are going to fail in the same way, right? Some have more affinity for a surface than others. Some have better cohesive strength than others. And we try and look at the combination of data and failure mode and then come up with a good, better, best approximation from that combination of data and failure mode.
That makes a lot of sense. So you did average peel strength until failure. What did you find when doing your T-peel test? Did you just go straight Hulk mode and start ripping things apart?
Well, not exactly. We documented the average peel strength, or the resistance to peel force, and we also looked at adhesion bond build over time. We also measured the failure modes, and we experienced a few different ones during the testing.
Yeah, so like I said, Hulk mode.
Well, not exactly. So we've had things like substrate failure, where the adhesive bond is stronger than the substrate we're adhering to.
Okay, what's the next one?
We also did some foam tear, right? So the foam is actually splitting. Again, adhesive is stronger than the bond of the internal bond strength of the foam material.
So kind of like Venom from the Spider-Man movie?
Not really, but there's other failure modes. There's like cohesive failure mode, where the adhesive actually is splitting, the internal bonds of the adhesive split.
Oh, well then that's the one that's like Venom, right?
No. There's also things like clean peel where you pull the adhesive and it comes cleanly off of the substrate.
Oh, I got this one. So clean cut like Superman.
And then we had other failure modes where maybe the adhesive stays on the substrate and removed from the aluminum. So in this case, an excellent bond.
Huh. Oh, that all makes sense. So you mentioned something about dwell time. What does that entail?
Yeah, so adhesives are viscoelastic, and so they're going to viscously flow and grab surface area over time. So we wanted to look at what's initial adhesion look like, and then as it builds over time, how does it get stronger?
Okay, so I'm looking at this graph. Why do some decrease in value?
Yeah, and this is kind of what I was highlighting. It's really important to look at the numbers, but also the failure mode. You have to do them together, because if you only look at one, you're only getting part of the picture. So you might have a higher value initially, and then if that value drops off, it could be because the failure mode has changed. And so now we may not be measuring adhesion anymore. We might be measuring the strength of the foam, because the foam might be tearing. So that's where you might see a decrease in the chart.
Okay, I'm on board with that. So Nick, we've talked a lot about pour-on products, but what about BISCO products? Do we use the same 3M adhesives for those, or is there a special one because it's silicone?
Well, we do have a special product for that. It's called 9731. It's a silicone acrylic differential double coat. So it has silicone adhesive on one side for bonding to the BISCO foam, and then it has an acrylic adhesive on the other side for bonding to your second substrate.
But what if you really wanted to use an acrylic adhesive on the BISCO?
Well, you can, but the surface has to be modified to enable adhesion of a different adhesive.
Surface modification like what?
Yep. So there are different ways to do this. You can either use an adhesion promoter or primer for the silicone surface before applying the adhesive, or another method is corona treatment of the silicone foam to enable the use of an acrylic adhesive.
Okay.
Jordan, I've done a lot of talking today. Is there anything you'd like to add?
Well, Nick, I'm glad you've asked. So we've taken all your technical data and simplified it down into two separate documents. First one is a 3M technical bulletin. That's a high-level process of the products that we use, as well as the procedure that you followed when you did your test. And then we simplified it down into a marketing document that goes through good, better, best of the Rogers products, as well as the 3M adhesives that tie to it.
So where can our customers go if they need more information?
Well, Nick, you're sure asking a whole lot of questions, but they can reach out to their local 3M, Marian, or Rogers rep.
Thanks for your time today, and please don't hesitate to reach out.